All right, so what we have here is a combined gas law problem, and one way you can tell is that is a gas undergoing a change. It's not just a gas in one container. Another big thing is you'll notice that you have multiple volumes listed and multiple pressures. So we have a volume at a certain pressure and temperature, and then you're given a new temperature and pressure. So that should be an indication that something's changing, and you're going to have to use the combined gas law, which is P1 times V1 over T1 equals P2 times V2 over T2. And you want to start these problems by just writing down everything you know. So the first thing we see is there's a volume, and the volume is 500 liters. And then it's at a certain pressure of 700 kPa and a certain temperature of 200 degrees Celsius. And since these are all talking about the same gas, the same conditions, I want to connect them by saying V1, P1, and T1. I want to make them all connected. I could have called them V2, P2, and T2, but whatever. These are the first ones listed. I'll call them V1, P1, and T1. It doesn't make a difference. So then the tank is cooled, and we want to know the new volume. So the new volume, V2, isn't given. So I'm going to put a question mark. And we know the new pressure, according to this, is 30 atmospheres. And we know the new temperature is 20 degrees Celsius. So we're almost ready to use our equation. We have all the variables are known except for one, but we do have to do a unit check. We need to make sure first the units are matching. So the volume, we have units of liters. That means our final answer is also going to end up in units of liters. Our pressures don't match. So that means we're going to have to convert one to the other. I like to get in the habit of converting to atmospheres because you can use atmospheres in the ideal gas law. So just a quick side note, I'm going to convert 700 kPa into atmospheres. So I look up the exchange rate. It's 101.3 kPa in 1 atmosphere. So I'm going to just 700 divided by 101.3. And I should get close to 7 based on this. And I end up with 6.9 atmospheres. So I'm just going to cross off the 700. I'm going to use 6.9 atmospheres from now on. Now the temperatures match, but there's still a problem, and that is you cannot use Celsius in any gas law problem. You can end up with 0, negative numbers. It just doesn't work. It has to be on absolute temperature. So to convert to Kelvin, you always add 273. So you might want to even do that as soon as you write down a Celsius temperature. For a gas law problem, you're not allowed to use them. So convert to Kelvin. So that's out, and this is 293 Kelvin. All right, so now we're ready to go. Usually I like to solve for the variable I'm looking for, but I know not many of you would probably like to do that, so we'll do it your way and just start plugging in numbers. So P1 is 6.9 atmospheres times V1, which is 500 liters, divided by T1, 473 Kelvin. That has to equal P2, which is 30 atmospheres, times V2, unknown, over 293 Kelvin, which is T2. Now we're going to start simplifying that. I'm going to start by figuring out what this equals. So 6.9 times 500 divided by 473, I get 7.29. I'm going to try not to round much until the very end. Over here, I get 30 divided by 293, and that's 0.102. And V2 stays as it is. It's in the numerator, so I can leave it right there. Now I'm going to solve for V2. So we divide both sides by 0.102 to get it by itself. And then I'm going to end up with V2 equals, so 7.29 divided by 0.102, 71. Now I can round a bit, 71.5 liters. So that is the new volume of this gas under these conditions. But let's not just stop there. Let's take a minute and just double check our answer. We know that this equation is true. So that means if I were to take my values for P1, V1, and T1 and plug them in, P1 times V1 over T1, they should equal my values on the other side. So let's double check that. If I take 6.9 times 500 divided by 473, I get 7.3. That is P1 times V1 over T1. If I've done this right, that should equal P2 times V2 over T2. So P2 is 30 times 71.5 divided by 293, and I get 7.32. Pretty close. So that checks out. This answer is probably right. So it's a good thing to do at the end just to make sure you didn't make an algebra mistake. It happens. Actually, this is my second time recording this video because I actually made a mistake while I was doing this. So double check your answers. It doesn't take long. It can save you a mistake. So until next time, I am Derek Genova. Have a delightful day.